Jai Sri Ram.
Go live. 1 second, sir. I'm reloading the page to see whether we are live or not, sir.
Do you want me to close it? Because I'm still there.
1 second, sir. I think, yeah, we are live, sir.
You're live now.
We are live, sir. I put it in a gallery view.
Do you hear me? So I turned off the.
Yeah.
Yeah.
You can turn off the.
I turned off the sound thing here.
In YouTube, yes, sir. In YouTube, yes,
Yeah,
sir.
that's true.
Just a second, sir. I will just switch the view to speaker view, and then I will mute my Zoom audio mic and then video, sir. So you can go, sir. You can start the session, sir.
Hello, everyone. Is there any delay, Murli?
So 30 seconds delay will be there in the YouTube, sir. But you can start because it's one-way communication now, sir. So you can just deliver your deliver the session, sir. Yes, sir. You can begin, sir.
Okay. So, ladies and gentlemen, I welcome you all. And I think I should start with the questions that I already have received from you. Am I audible?
Yes, sir. You are audible, sir. I checked in the YouTube, sir.
Very good. So there are some questions that I read. I actually should answer all of them here technically, but I may not because I don't have all the tools and other things here. So what is there? I'll see the questions and I read them and I'll try to answer here. And the questions I cannot answer right now because of some technicalities, I can share it later with you. Maybe I contact you directly and so on. So Akib Rashid Ansari has posted a number of questions from the forum actually. We will answer most of them in the forum, but let's talk about other questions. So Nilesh Varma, he wrote two questions. How to practice fold out crop pattern, I have little problem. And how to find fold type by outcrop pattern. Nilesh, first of all, thank you for asking this question. The primary objective of looking at fold out crops in the field is essentially to identify the nature of the fold. Now, once you see a folded pattern, the first and foremost thing that you should try to figure out that where you are in the fold. So if it is a large scale fold, you try to figure out that whether you are in the limb section of the fold or in the hinge section of the fold. And this is very easily understood simply by understanding the relationship between the bedding plane or the form surface of the fold and the corresponding foliation. Not necessarily the foliation you see is exactly the same, of the same fold, I mean, but there are some evidences that you can check. Unfortunately, I cannot take you to the field in this course, but this is how it happens. And then once you understand that where you are, if you know you are in the limb zone, then you look at the relationship between the strike and deep of the form surface and also the cleavage. And then you also then you try to figure out that which side you should get the hinge, and then you go to the hinge section, and then you take the orientation of this day of all the planes and plot it in the stereo net, and readily you can figure out that what is the uh, type of the fold that you are looking at. So that's one of the easiest ways to look at. There are various other ways, and you can figure it out when you go in the field with your teacher, right? Uh, Akib asked another question. So first, I try to answer the questions that I have already received via Google document. Akib has asked one more question. I would like to know briefly about the areas of current research in structural geology or any other field in general. Akib, this is a very good question, but I don't think we spent time on that. Maybe I add a lecture, or maybe in the forum I post something by writing that what are the current directions of structural geology research. I'm not an expert of overall geology, but structural geology I certainly can prepare a document and share with you. Then one question is, you said azimuth direction of strike and deep are perpendicular. Why do they need to be perpendicular always? Now this is exactly how it should be. Say this is a bedding plane. Okay, I'm not sure if you can see this. And then it is dipping like this. So clearly this is the strike, and the bed is dipping in this way. So this is the azimuth of the strike, and if the bed is dipping this way, then if I bring it up, then the azimuth of the dip direction is this, right? So the strike and the azimuth of the dip direction is always perpendicular. This has to be, but you have to understand that it is a true dip, right? If it is apparent dip, it may not happen this way. Then you asked that how can this is when I was teaching the eigenvalues and eigenvectors. So first you have to understand this is not a point, right? These two are the vectors, okay, 0 1 and 1 0, and there are some connecting questions. I'll discuss it in the forum. Now let me come back to your listed questions here. So yes. So Anubhav, they wrote a question that internship. Yes, you can, if you score well, the NPTEL team will contact you, and then you can come here and work with me and with my research group in IIT-Kanpur. Outcrop term, please explain outcrop term. So outcrop is nothing but you just you go to the field, you see an exposure of rocks, okay, and this is outcrop. So if you go to Himalaya, you see there are rocks. So if the rocks are exposed on the surface, we call it outcrop, right? Uh, Generally, it is a scale independent term, but at least you can overview the things, then we call it outcrop. So Murli has also answered you that due to COVID, we did not conduct internship for last 2 semesters. When situation improves, then we will make a decision. So eventually the chances are there, so you can come. Orko Das asked a question, sir, can you explain stress analysis? Could you please elaborate your question, Orko? I'm not really getting it. What do you mean by stress analysis? So, I mean, there are many tools, or there are many ways you can understand what is stress, and there are many ways from field you can figure out that what was the orientation of the principal axis of stresses. Okay. Mm, kindly explain apparent dip angle and direction. So any dip angle or dip direction which is not true dip is apparent dip, and of course apparent dip direction. So true dip is essentially it has to be perpendicular to the strike. Okay, and if you don't measure it in that manner, then it has to be apparent dip. Any more question? Nilesh, I think you joined late. I just explained how to interpret the type of fold by outcrop pattern. Uh, so only possibility is that this would remain open. So you can come back and see it. Now right now it is live, but this is how it is. So in the class I explained, and I also explained a while ago. So you can check. Any more questions? Yeah, no problem, Nilesh. I mean, the point is you have to identify in the field where you are in the fold, whether you are in the limb or in the hinge. Okay. So, and once you know that, it is okay. Why we take two components in stress and elaborate tensors? Uh, I'm not getting your question properly, Orko. Uh, but as I explained, that stress on a surface is a vector. But when you come to a point, then what you do, you form a little cube, right? I should have something here. Yep. So you can consider this as a very little cube, and then say the stress, say you are acting some force on it, right? And then you can resolve the force on these three surfaces, this one, and facing towards you. So clearly, if because this is three-dimensional object, so you should have one normal component and then one, because this is a reference frame and we are dealing continuum mechanics. So one component should be along this direction and one component should be along this direction. Okay, so actually, if it is in three dimension, for each direction, you need three components. So you have one face, two face, and three face. So first phase, second phase, third phase. So for each phase, you need three components of stresses. And out of these three, one is normal and two is along the plane. So the normal is known as normal stress, and which are acting along the plane are shear stresses. So for each phase, you have three components. So altogether, you come up with 9 components. Unproctored exam, I think Murli from the NPTEL team, he's here, he can explain.
Sir, already posted a reply to that.
Yes, I see you have given it.
Right, sir.
Orghodip Ghosh, please recommend few books on maths for structural geology. Okay, one book I certainly, I mean, what you need is simple algebra, vector algebra in particular, and a little bit of calculus. That's it. So +2 standard is absolutely fine. Okay. So Spiegel is I can recommend a book of Spiegel. I should have it here, or maybe not here. I have in my home probably. So Spiegel, Fundamentals of Mathematics, you can check that. Smear shadow. What is that? Nilesh, where did you get it, this term? You please write, Nilesh, then I answer meanwhile Bharat Singh Lodhi's question. What's difference between bedding plan and cleavage? I think you wanted to mention bedding plane. So Bharat, bedding plane is nothing but the original layer. So sedimentary layers, primary layers are known as bedding planes. Okay. And cleavage is essentially something that is being produced because of deformation. So bedding is a process, a sedimentary process. You have sediments being deposited, and then this is how you form bedding planes. So these are primary things. And then you form cleavage while you deform the entire rock suite. And this is how it works. Smear shadow. I think I read this term somewhere. I have to look at English, and then I'll come back to you. Oh, there was a question in assignment. Dripto, are you here? So you may answer. You may write here if you are around. Just write the answer in the comment box for Nilesh. Okay. Yeah. So meanwhile, before any other questions come, Murli has mentioned a very important point that tomorrow till 5 p.m. you can register for this NPTEL course. So please do register. Yes, Bharat, go on. I mean, technically I should be here 45 more minutes. So ask questions. Penny contemporaneous structure. Penny contemporaneous structure, Bharat, is something that is contemporaneous while the structure itself is being forming. So I don't know if you have heard the term called seismites. So basically you have sedimentation happening, and then but the layers still are with water. It is not lithified. It did not become the rock. So it is still happening on a basin or on a flat surface, wherever. And then imagine you have an earthquake. So the entire basin will shake, and this unlithified soft layers will deform, right? So the deformation before lithification is known as a penny contemporaneous structure. And there are many such structures. I think I showed you a few, like convolute structures or load casts, flute casts. All these are kind of penny contemporaneous structure. If you do field work in some terrains of India, you can see all these features. Overturned cross bedding is a penny contemporaneous structure. Any more question? Very good, Bharat. Thank you. Please type your questions if you have, otherwise there is no point of staying online. What is the basic difference between cleavage, banding, and segregation banding? Wow. Dripta, do you have an answer for that? These are some kind of old terms or maybe some locally used terms. I'm not familiar with. Actually, in modern structural geology, these kind of terms are not used very frequently, but certainly relevant for people who actually work in detail with cleavage and these kind of things. But I'm not familiar with these terms. The terminology says me something, but I don't want to answer you without being confident on this. So I take a note of this and then I'll answer you later, Nilesh. But Dripta, if you have, or Avinash, if you have any answer to this. Okay, so yeah, so Nilesh will come back to you on this cleavage banding and segregation banding. When are you going to release the assignment answers, Dripto? I think we should release after each assignment or not? How are you doing that? So these assignments and other things are generally is being dealt by the teaching assistant. So Dripto and Avinash does it. Okay, so he answered it. And then Niru, sir, how to calculate normal stress? I think I gave the answers. I showed how to calculate normal stress. You should look at lecture number 9, I believe. Yes. You come to lecture number 9, slide 26. So there is given, so normal stress and shear stress is how you calculate if you know the stress tensor. How to determine the type of fault corresponding no, sorry, how to determine type of fault when dip and rake is given. This is geometrical problem. We should learn more on this fault. So there are actually some lab lectures on that. So once these values are there, so you need to use both graphical method and StereoNet to figure out this. But you can also use your intelligence. So if you know the dip means say deep angle and the deep direction, and if you also know the pitch or rec, then you imagine by yourself, then you can figure it out. So you have to think intelligently. Bharat sir, please give a solution for numerical Q in the assignment solution. So TAs can help you with that, Bharat. Mm, Sankalp, your question is enough to prepare for structural geology for GATE and NET. Technically, yes, but lectures are in all cases not sufficient. You have to read books. Okay, so reading a book is very, very important, and for GATE and NET there are many other uh, because in GATE and NET the questions are MCQs. So in my course or reading a book, you will understand, you'll clear your basics. But GATE, NET, or all the exams that have MCQs, these things do have some, they do require some special skills. So better you practice those. Huh? But to clear your basics about structural geology, yes, and that may help you to solve the MCQs. Niru Dhiman, I can't understand properly. So Niru, could you please tell us, tell me what you're not understanding in the entire course, or Niru, if you're here, could you please write what you are not understanding? That can help me to answer your question. So Avinash and Dripto have answered some of your questions already. Thank you, Dripto and Avinash. Nilesh, thank you very much. And I have been asking you repeatedly, not to you, but to all that provide weekly feedbacks. So if you provide that, that would be helpful for me and also for the NPTEL team to work better for you, right? So please provide weekly recommendations or weekly feedback of the course. Orko's question is, can you recommend few books for clearing concepts? So Orko, at the very beginning, I gave you first lecture. I think I suggested 3 books. These 3 books are fantastic enough. If you read from the top to bottom, you are a good structural geologist. I mean, read and understand. Okay, and they are available in internet. So you have to just Google properly. NAPE, didn't I explain in the class, Sankalp? So NAPE is nothing but that you are having a fold, say like this. Uh, in a so in other words, say you are having a thrust and not fold, sorry, thrust, and then low angle thrust. So it is moving, 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 and then it is going, and then finally it is there. So it is just a different type of rock nowhere. So the peak of Everest and everything is a kind of nappe. Okay, there are fantastic sketches in the lecture, so you can see that. Bharat Singh Lodhi, yes, you can consider this course is good enough, but as I answered before, that you have to read books and clear your concepts. So Dripto has given names of a few books. So Hakon Fossen, I'll recommend it. Yes, Sparks book is also very, very good. You should also consult that book. Pick any book and read from top to bottom. That's it, first page to last page. So Sankalp, when we start fault there, you actually can see the, we have explained NAPE, CLIPE, all related structures, large scale structures. Any more question? You're welcome, Sankalp and Bharat. Sometimes while plotting a pole, the direction given does not lie in either side, east or west region. So how to mark deep angle on stereo net? I'm not getting it properly. Your name is Be It. So I'm not getting the answer. So could you please send me the question so I can have a look and reply you back. But if your name is Be It in YouTube, it's difficult for me to find out who you are. So you please write your name. I can or Dripto or Avinash can answer your question later. So if you don't have any more question, we can close this session, Murli. And yeah, and they are always welcome to ask questions in the discussion forum.
Yes, sir. We can end the session, sir.
So thank you very much, everyone. Okay, Sankalp has asked one question. In the first lecture, sir, you said lineation is in 1D. So if it is in 1D, how can... Oh. The linear structure itself is one-dimensional, right? So it's like a pen, right? So an individual lineation is one dimension. Now, if you have multiple lineations, then in the entire block, the structure is three-dimensional. But when you think of the lineation itself, it is one-dimensional structure. So we learned that we learn later that in a shear zone, it generally marks the x direction. Okay. Any more question, gentlemen and ladies?
Sir, shall we stop the broadcast? Students are
Yes,
not posting questions.
I think we should do it.
Right, sir. Thank you so much, sir, for your valuable time.
Yeah, no problem.
Yes, sir.
So
So I'll just stop the broadcast.
yeah, so goodbye everyone. I'll see you again in the discussion forum, and please do register for the examination. The deadline is tomorrow at 5. Okay, thank you and good night.